Hi, in this lesson, we'll go over how to use variables in a program. As we saw before, it's very easy to make calculations with Python and keep it organized with our text. Here's the last example, when we were calculating the area of a rectangle. The problem is that we can't really remember what the 15 and 8 mean. In programming, just like in math, we don't just use numbers in our calculations, we use something called variables. Introducing variables. A variable is like a box, with a name that holds a value to be stored throughout a program. Let's take this box here and name it length. Now, let's store the value 15 inside of it. You can print the value of the variable by using the name in the print statement. Notice there are no quotes around the name. This is because it's a variable name, not a string we're trying to print. To create the variable in Python, we have what is called an assignment statement. There are two parts to the statement: the name of the variable, length, and the value we're assigning to it, 15. Again, when I run this program, the print statement prints the value of the variable, not the name. Since we're storing a whole number, the type of the variable is called an integer variable. As a reminder, an integer is any positive or negative whole number that doesn't have a decimal. We can also store a string or text in a variable like the word rectangle. We have a similar assignment statement as before. The name is shape, but now the stored value is rectangle. We need quotes around rectangle because it's a string we're storing, in contrast to the variable name. When we print shape, the value still prints, which this time is the word rectangle. Since the variable is storing a string, we call this a string variable. The last thing we need to talk about is how to name a variable. There are a few simple guidelines to follow here. Variable names must be descriptive, meaning the name must describe what the variable is representing. Having a variable named variable means nothing, whereas count is telling us what it is doing. Variables can't start with a number, and most often should start with a lowercase letter. Instead of one length, change it to length_1. All letters in a variable name should be lowercase. So instead of width with a capital W, we should have width with a lowercase w. Variable names should use underscores between words. So instead of shape space type, we would write shape_type. Okay, now let's take our last example and incorporate variables. The first step is to add the variable assignment lines. We created the length variable and assigned it the value of 15. We create the width variable and assign it the value of 8. The second step is to replace 15 and 8 in the print statement with the variable names. Already this looks a lot more clear. I know what the numbers mean now. Notice the output has not changed. Remember, there should be no quotes around the variable names. And finally, let's create a variable called area, assigning the calculation length times width. Now, we can use the variable area in our print statement. Now, doesn't this look so much more organized? Variables are an incredibly important part of programming. Poor use of variables can result in headaches, mistakes, and inefficiencies. Now to the live editor to look at more examples. Here's the code from the earlier example where we calculated the area of a rectangle. The rectangle has a length of 15 and a width of 8, and we calculated and printed the area. Using these measurements, let's now calculate the perimeter of the rectangle. The perimeter of a rectangle is equal to 2 times the length plus 2 times the width. To make our code easier to read, let's first create a variable called perimeter. Let's assign the perimeter variable the value of the calculation, which is 2 times the length plus 2 times the width. Now, let's print the perimeter to see our results. We can have a print statement that matches the one that we have for our area. So we can write print the rectangle's perimeter is. And then using the string function, we'll convert the perimeter into a string. And then we'll also add the unit, which is centimeters. Let's run our code to see the results. The rectangle's perimeter is 46 centimeters. Nice. What's nice about this program is that we can also change the variables at the top of the program and rerun the code to see different areas and perimeters for other rectangles. So let's say we had a rectangle with a length of 5 and a width of 4. When I run the code, now the rectangle's perimeter is 18 centimeters, and the area is 20 centimeters squared. Now it's your turn to try it.